Welcome you all the lecture series of data structures. In today's video, we have seen one case study on the binary search tree. So this is the problem statement. A library wants to implement a client book management system to store and retrieve the book information. So the system should allow the book insertion, adding a new books, and book deletion, removing the books, and book search, finding the specific book, and book traversal, displaying all books in an alphabetical order. So this is the constraints we have to do. Suppose we have the following books: data structures, algorithms, computer networks, introduction to Java, machine learning. So construct the suitable tree for the above list of books. So you have to construct the tree for the the above book. So this is the problem statement. So how to do means we have to first we have to know about the BST. So using the binary search tree, we are going to insert the given tree because it is in the order nu சொல்லிருக்காங்க. So binary search tree is nothing but it is a binary tree. For every node x in the tree, the values of all the keys in its left subtree is lesser values than the key value in x, and all the values of all the values of all the keys in the right subtree are the larger value. So this is the definition of a binary search tree. So using that you have to insert the particular books in the binary search tree. So before going into do, we have to find out what is the insertion operation and what is the rules. So the binary insertion operation is performed to insert the element in the binary search tree. So what is the rules means the insertion of a key always takes place as the child of some leaf node. So the insertion of a new node is always takes place as a child of some leaf node. So for finding out the suitable leaf node is a important task. Consider the following example where key is equal to 40 to be inserted means you have to check with the root node. If the key is equal to means you can if the key is lesser or greater values compared with the root node. If it is அப்படினா, if it is a lesser values அப்படினா, you have to move towards the left subtree, and if it is a greater value means move towards the right subtree and find out the appropriate place to insert the given key value. This is the insertion procedure for the BST. Now we will find out the solution to that given problem. So before going into the solution, we have to find out the what is that constraints, and you have to find considered in the BST. So the each node represents the book with attributes title, author, and publication date. So each node represents the book. So the left child node has a title less than its parent node because we have to find do in a alphabetical order. So the left child node has a title less than its parent node, and the right child node contains the title greater than its parent node. So the root node is the middle value of the books. Okay, this is the BST constraint for the given problem. So the every node represents the book with the author name, title, and the publication date. And the left child node has a title less than its parent node. Right child has the title greater than its parent node. So now we move to the solution. So we have to insert the element in terms of an ordering of a input given. So the first book is the data structure. So that is the root node. So insert the data structure as a root node. So the second input is the algorithm book. Book name is algorithm. So compared with the alphabetical order, the A is lesser than D. So move towards the left side of data structure and insert the particular node. So the algorithm is inserted the left child of data structures. So the next reading book is computer networks. So the compared with D and C is lesser values. So move towards the left subtree. Again you have a root node. Compare the algorithms and the computer networks. That C is a greater value. So insert the computer networks book at the right child of algorithm book. So next book is the introduction to Java. So that is also compared with the root node. So I is greater than the D. So to move towards the right side of data structures book and insert the corresponding introduction to Java book in the right child of data structure. Next is a reading book is a machine learning. So that alphabetical start with M. So compare the data structure with machine learning. It is a greater. So move towards the right side. Again the I is compared with M. So M is a greater value. So move towards the right side of introduction to Java book and insert the machine learning as a leaf node of right child of introduction to Java book. So this is the way we can insert the set of books in the library. So library is a so insert the book in a or in the suitable binary tree. So that is a binary search tree.